Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Fahmi bin Ferus. My matric number is 2312047. Today I will talk about definition of coupling in power system. So what is coupling in power system in general? Coupling in power system refer to the electrical interconnection between the various components such as a generator, transformer, transmission lines, load, and now increasingly significantly in renewable energy resources. So this coupling allows that the flow energy of a synchronized voltage, frequency, and a power stability across the grid. It can be physically and mechanically and or digital. So I will talk about two type of the main coupling in power system. The first one is electrical coupling. So as you can see in the power in the slide, I will show the example. But firstly I will talk about the definition. The definition of electrical coupling is interaction between two different parts of power network through the conductor or electrical component. So I will talk about the example as you know in the slide. As you can see in the slide, the coupling between generator and load via the transmission line. So the other example is interconnected grid, a national grid or international interconnected. So what is the function or the key role of this electrical coupling? So the key role is enable power flow across the system and maintain the system reliability. So the second one is electronic coupling. So the definition occur due to the mutual inductance or the capacitance between nearby power line or electrical equipment. So for example, the parallel transmission line causing the interface or the crosstalk between each other. So other than that is the transformer using a magnetic coupling to transfer the energy into the electrical supply at the end of the product. So last one is what is the function or key role of the electrical coupling. So the function is essential in a power transfer through the transformer, but can cause interference if it's not managed in one system, and it can be a disaster to the system, or it can cause the many broken parts in that system. Thank you. That's all for me. So right now I will talk about the future development coupling in power system. So the first one is advanced power electronic coupling. The power electronic coupling uses devices like a converter, inverter, and solid state transformer to connect the different part of the power system, especially AC to DC, renewable energy system, and a microgrid. For example, that I take for the future development is multi-terminal HVDC system. So what is HVDC? HVDC is high voltage DC. Because unlike the traditional point-to-point HVDC, the future system will only allow the input or output nodes to the share power across the long distance. So you must know about the what is the important. So the important is enable precise control over power flow, improve voltage frequency stability, and support the integration of the intermittent renewable energy resources. So the second one is the increase AC-DC hybrid grid, as you see in the picture. So what is the increased AC-DC hybrid grid? So the most power system today is AC based, but DC is becoming more common nowadays due to the growth of the renewable storage and HVDC transmission. In the future, power system will operate as a hybrid AC-DC network where both type of power coexist and couple intelligently. So it work synchronously together. So the future tense is the medium voltage DC MVDC system for the industrial and urban distribution. So what is the method of this future development? So the DC is more efficient for long distance and high power transmission. So while the hybrid coupling allow the flexible to control and reduce loss and a greater stability, reduce the loss power and give a greater stability. So the other thing is the easy integration of solar panel, battery and EV which operate natively on a DC right now in this world. So the third one is coupling with energy storage system. So energy storage system, especially battery energy storage system BESS, play as a critical role in a balancing supply and a demand right now. Coupling storage with the grid enable the fast response, backup power and also frequency regulation to the system. So the future tense that we get is hydrogen energy storage will be used in a couple surplus renewable energy with the long duration of the storage. So the important things of this future development is improve reliability when the solar wind production is unstable. So it also reduce the need for fossil fuels based peaker plant.
Now I'm going to talk about mechanism for sector coupling. First, there's a many mechanism, but I just want to point out three. The first one is electrification of end-use sector. On mechanism part, direct replacement of fossil fuel use with electricity. For example, electric vehicle (EVs) are replacing combustion engines. That is on transport sector. And then for the heating sector is electric heat pumps replacing gas or oil boilers. The impact of this increase electricity demand but allow renewable energy to decarbonize traditionally fossil fuel heavy sector. Right, moving on to the second point, that is energy storage and demand response. So for the mechanism, align energy use with availability of renewable electricity. About the tech, thermal energy storage. Example is storing heat from P to H, battery store for EVs or grid. And the last one is smart appliance and industrial loads are participating in demand side management, DSM. For the sector coupling rules, provides flexibility and stability to the grid, making better use of renewables. And for the third point, we're gonna talk about hydrogen as a coupling vector. For the mechanism, it has two. The first one is act as an energy carrier between electricity, transport, industry, and heating. The second point is hydrogen can be stored, transported, and converted back to electricity or used directly. Examples: fuel cell vehicle, and the third one is hydrogen is used in industrial process like steel making, ammonia production. That's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. So now I'm going to continue in sector coupling in Malaysia. So in Malaysia, we usually use power like coal, gas and oil, and some of Malaysian citizens also use solar and hydro power resources. And the main problem of Malaysia is that our sectors like transport, power and industry are still not connected. So there are a few ways of Malaysia governments do towards sector coupling. So the first one is electric vehicles. Malaysia launched EV policy in 2021, and EVs link transport to electricity. So the second one is solar rooftop. So nowadays homes and businesses produce solar power, so it helps connect building to the power grid. And the last one is green hydrogen. So this is a very new power resources that been announced by Malaysia governments. Malaysia plans to use hydrogen for clean fuel in transport and industry. So now I'm going to talk about the challenges and opportunities that face in sector coupling in Malaysia. So for the challenges, the first one is we lack of integration between energy sectors. The second one is the grid not yet fully smart or flexible. And the second one is the policy gaps in Malaysian laws. And the last one is the Malaysia resources is heavily reliant on natural gas and coal. So what are the opportunities that we have? So the first one is EV plus charging infrastructure. The second one is the Malaysia is trying to introduce a new power, which is hydrogen economy. And the last one is energy efficiency measures in building and industries. So into the next one.
Okay, Assalamualaikum warahmatullahi wabarakatuh. So I'm going to talk about sector coupling in power system and the implementation of it in worldwide. So of course there are many countries that implement this system. As example, Malaysia, like my friend talks about just now. So I'm gonna give three countries as example. So first of all, we got Germany. Germany is a leader in sector coupling. In German, it is called Sektorkopplung, and it is mainly power to gas plants. Example, wind gas projects convert surplus wind energy to hydrogen or methane. After that, we got China. China is a leading producer and user of electric vehicles, including buses and trucks. China is building green hydrogen plants in regions with high solar or wind output. Example, in Inner Mongolia, they build many green hydrogen plants around there. So lastly, we got United States. It is a bit decentralized, but it's still growing. As example, California uses smart grids and EVs to balance solar-heavy generation. And after that, we got New York that start investing in heat pump adoption for residential heating. So next, so the common technologies in use worldwide. First of all, electrical vehicles (EVs). It is really widely used around the world right now. Countries that mostly use it are Norway, China, Germany, USA, and Netherlands. So it is used to electrify transport, reduce oil use, and act as mobile energy storage. After that, we have heat pumps. Countries that use it are Denmark, Germany, USA, and Switzerland. So it is electrify building heating or cooling using ambient heat. It is also a very efficient to use. So after that, we got power to gas or hydrogen. So like I said just now, it's mainly used in Germany, of course, included in Japan, China, and Netherlands. So it is mainly converting excess renewable electricity into hydrogen for use in transport, heating, or industry. And after that, we got smart grids or demand response. So it is mainly applied in USA, EU, and South Korea. It coordinates electricity supply and demand using real-time data, and also supports integration of EVs and renewables. And lastly, we got district heating. It is commonly used in Denmark, Sweden, and Finland. It centralizes heating networks powered by electricity or waste heat, mainly used in urban areas. So that's all for me.
Moving on to the next slide, coupled power system often rely on distant backup plans when demand spikes. If this fossil fuel emission increase, coupling also affects how much renewable energy can be accepted. If system isn't stable enough, wind or solar power system might be shut off. Finally, long transmission path created by coupling cause higher resistive losses, which mean more electricity must be generated, increasing the environmental burden. Okay, next, when faults spread across coupled grid, they can cause blackout that force buildings or hospitals to run diesel generator, which highly polluted. But on the positive side, smartly managed coupling can increase its efficiency, which reducing the total emissions. Also, line carrying heavy current heat up and can warm nearby land or soil, disrupting ecosystem and cause localized thermal pollution. Okay, that's all from us. Thank you.